Hello and welcome to the next class of Introduction to Astronomy. My name is Hannah Buckner and I'm one of the AmeriCorps educators here at the museum, and I do Earth and space science. And for the last few weeks, we've been delving into the different topics of astronomy, from what's in our solar system to last week we talked about Earth's rotation and the revolution and how that makes years. And so today's class, we will be talking about meteoroids and asteroids and talking about a little bit about the things that kind of come from that. So let us get started. So I'm going to share my screen and bring it to the PowerPoint. So like I said, we're doing an introduction to meteoroids and asteroids, and we'll be talking a little bit about that. But first, we're going to talk about kind of what we touched on in the last class in case you missed it or needed a refresher. So we talked about how the Earth spins on its axis and completes one full turn every 24 hours. So that's what generates a day or a day-to-night cycle. And then the Earth, at the same time, is orbiting around the sun and completes one full orbit or revolution in 1 year, or 365 days. So the Earth spins on its axis 365 times as it goes around the sun, and that creates 1 year. And this picture that you see on the right is a photograph that I took myself while I was in Florida, and you'll see right in the middle upper half of the picture is Orion on its side, and I thought that was a cool picture to share. So let's get started. So meteoroids, meteorites, meteors, and asteroids. That's a whole mouthful, very repetitive. In this class, we'll be discussing what all of these objects are, what they're made of, where we can find them, and what do they look like. So yeah, let's get started. Meteoroids. So we don't actually have many pictures of meteoroids besides asteroids. Meteoroids are any object in space that ranges from the size of a speck of dust, a single speck of dust, to small asteroids. And we typically know these as space rocks. And you'll hear about them a lot in many museums where they have examples of asteroids or meteoroids where they've either been chipped off from an excavation done by a robot that was sent out on a mission out into space, or sometimes there'll be meteorites that will be on exhibit, and we'll talk about that, what those are, in a few minutes. But one thing to know is that meteoroids are not all created equal, like us humans. Meteoroids are classified actually in different materials. So an M-type meteoroid might mean, well, if we have a meteoroid and it's an M-type, that means that it's composed of metal, but if it's an S-type, then it means that it's made with silicone. So there are many different types of materials that can make up a meteoroid, and it can tell us a little bit about where it formed or what kind of body it might have come from. And typically we see that meteoroids actually come from larger bodies that were broken off or blown off from other bits. So sometimes they come from comets or they come from asteroids. Even some came from the moon and other planets. And being from these places, they can have, like we said, those different materials, or they can even have combinations where we see sometimes they're rock, sometimes they're metal, or they're a combination of the two. Sometimes they can be different types of these materials. So meteors and meteor showers, we tend to hear this a lot more than meteoroids, just because it's a little bit shorter. So meteors are a type of meteoroid that have entered an atmosphere. It doesn't necessarily have to be Earth's atmosphere. It can be Mars or Jupiter, Saturn, any place that has an atmosphere, like Venus too. So a meteoroid has entered the atmosphere and is entering at a high speed and we see them burning up. And when we see them burning, we call them shooting stars. And then sometimes we also call them fireballs when they come down through the atmosphere, but they don't actually touch the ground. They explode in the air. And you might have heard in, I believe it was 2014 or 2016, when in Russia, in a remote part of Russia, an asteroid actually came down. It was coming at 11 meters per second. It's pretty big. It was the size of a house and exploded 14 miles above the surface. And it actually, for about 200 miles, shattered glass from houses, cars. I believe some phones broke too, and people sustained injuries from that because it was quite dangerous. It was as if TNT had exploded in the atmosphere. So meteor showers are when we see meteors happening very frequently in a certain amount of time. So you always know that meteors are always coming through the atmosphere. There is always something burning up in the atmosphere. You can always see or observe several meteors per hour, actually. If you just look at one span of your sky, you will probably see at least one or two. Just requires some patience. So some of these meteor showers occur at regular intervals, and that's because as the Earth is orbiting around the sun, it's actually passing through trails of dust that were left behind by a comet or sometimes an asteroid. So when we are observing this, it literally means that we are passing through dust that has been left behind by these objects. And these objects that are burning up in the sky tend to be between the size of a grain of sand and a pea. And because of these sizes, they typically burn up before they reach the ground. And this is a view of the Perseids above the forest. Okay, so meteorites. Meteorites are very special because they are meteoroids that have become meteors as they pass through the atmosphere, and they have survived this very treacherous and harrowing journey through Earth's atmosphere where they are burning up at tremendous heat and speeds that the friction is causing this ignition for it to burn. And so meteorites have actually hit the ground and are showing us little like time capsules of space. They can really dictate, well, not dictate, but they can tell us a lot about our region of space and how our solar system formed. So actually, this image that you're seeing on the right is called Black Beauty, and it's a meteorite that came from Mars. So it's actually a bit of rock that broke off from Mars, made its way somehow over to us, and as a meteoroid, it passed through our atmosphere, becoming a meteor, and then as it somehow survived, and it looks like it's about the size of a small ball, so maybe about the size of my palm, so it was significantly bigger, and it was reduced to this size. And you can actually see some of the burning and scoring on the actual image itself. And then it hit the ground, and by seeing it and analyzing the components of it, we were actually able to tell that it came from Mars and some of the pieces of it. So we know how old it might be. So they're very useful actually for us to be able to know what our solar system is composed of and how it compares to our own planet. And so these are some other meteorites that have been found. The one on the far left is a meteorite that was found in Antarctica. And so you can see that the scientists are actually measuring it and taking photographic evidence of it to capture what they found. And this kind of shows next to the other picture that we have of a meteorite that was found, that meteorites can really be found in all sorts of locations around the world. It's not just in one specific portion of Earth. It's going to be everywhere, which also emphasizes the point that you can see a meteor at any point in time if you just wanted to take some patience and look up at the sky and see if you can see some streakers. So on the top right is a meteorite at the far right corner that was found in a desert. And so a scientist was looking around for them and found this one. And then the one on the bottom is also another meteorite that was composed of iron. So next we have asteroids. And asteroids are very common to talk about in science fiction, and we see them all the time. So asteroids, if you've been watching some of my other classes, we've seen that asteroids actually sometimes compose up dwarf planets. And so asteroids are also sometimes called minor planets because they can really have the same shape of planets, but not really have the same build or composure. So they will seem like planets, but they don't necessarily fit the same structure. And sometimes asteroids do have small, I think we've seen that there was an asteroid that did have a very small amount of atmosphere, but that could have also been it could have been disputed in research that was done on it. But for what we do know, asteroids are rocky, airless, meaning that they don't have any atmosphere. They can't contain any gas to generate atmosphere. There are remnants that have been left over from the early formation of our solar system about 4.6 billion years ago. So asteroids are a really great way to look back in time and see what it was really like in our solar system as it was forming, as it was a baby and forming and growing into the mature, well, not mature, it's teenage, maybe middle-aged years, where we can see how objects were forming and what the solar system was really composed of at the beginning of its time. And that can also tell us about what the whole universe was like at that time, with how some stars were forming rather than some really big stars or some really small stars. It can really tell us about the behavior and the life expectancy of the solar system, of the universe. So as of right now, we know that there are about 957,888, so almost a million asteroids. That's a lot. And actually, majority of these asteroids are found in the main asteroid belt, which is orbiting the sun between Mars and Jupiter. So as you may remember, there are several different belts. There's the asteroid belt, the Kuiper belt, and then the Oort cloud. And so majority of asteroids are actually found in that asteroid belt that's orbiting between Mars and Jupiter. And these asteroids are all very different, just like meteors and meteorites and meteoroids. Most that we have, well, what we have found is that the asteroids that we have found range in size from 33 feet, which is probably 60 meters. No, 33 feet, which is about the size of, it'd be like a really long school bus, to 329 miles, which would probably be from St. Johnsbury, Vermont, down to probably Atlantic City, New Jersey. Ooh, New Jersey. But surprisingly, the 957,888 asteroids that we have found, their total mass, or the total amount that they weigh, is actually less than the mass of the Earth's moon. So this thing that we see out in the sky is actually much heavier than all these different asteroids, despite their variances in size. So that's actually something that's really interesting to note. And I wonder, as I'm talking about that, does that surprise you that there's this many asteroids and they actually weigh less than the moon? Email me about it if you would like to ask me about it. Some asteroids that I wanted to bring up to you that are really interesting are these three. So the one on the far left is called 101955 Bennu. So Bennu, or Bennu, your choice. So we know that this asteroid probably broke off from a much larger asteroid that was mainly composed of carbon, which is one of the lighter elements on the table of elements. Probably broke off from a carbon-rich asteroid about 700 million to 2 billion years ago. So it formed kind of when the solar system was in its quarter life, or a little bit later than that. So it knew the solar system when it was much younger, but definitely not like at the early beginning. It likely formed in the main asteroid belt between Mars and Jupiter, but since then it has actually migrated towards the Earth, and it actually may contain the organic molecules or the strands of atoms that have chemically bonded together that are thought to be similar to those that were involved in the start of life on Earth. And so it's possible that if we do research on this, we may actually find the start for life because the material is so old. And actually, this asteroid is bigger than the Empire State Building in New York City. So that Empire State Building is 443 meters, about, that's how tall it is. This asteroid's actually wide. It's about 500 meters. So it's very long, very big. The next one on the top right is 10199 Chariklo. I'm hoping I'm saying that right. It's a Greek name. This asteroid was actually found on the 15th of February, 1997 by the Space Watch team at University of Arizona's Lunar and Planetary Lab. And this was actually the first asteroid to be found with a ring system, meaning it has rings like Jupiter and Saturn, and actually Neptune and Uranus, if you didn't know that they actually had rings. So all of the gas giants, or the gas giants and the ice giants, have rings around their solar system, around the planets. And it's one of the largest known asteroids, actually. The only one, maybe it's Psyche. But yeah, this is the largest member of an asteroid class known as the Centaurs, which is pretty funny to me because Karika was actually named after the wife of Chiron, he is a character in Greek mythology who is a centaur, and he trained heroes. And so it's funny that they named his wife after the group of centaur classes for the asteroids. And it actually orbits between Saturn and Uranus in the outer solar system. So it's not like the majority of asteroids that are orbiting in that main asteroid belt between Mars and Jupiter. It's actually much further out. And then this last one is actually very interesting. Its name is 16 Psyche, and it is the second largest asteroid in the asteroid belt. And it actually is pretty close to being considered a dwarf planet like Ceres. It's just that I think it has to do with the actual shape of the asteroid, that it hasn't actually become categorized as a dwarf planet. It is a giant metal asteroid that has a diameter of about 140 miles, also known as the distance between LA, or Los Angeles, and San Diego. So It's very, very big. And if it hit Earth, it would probably destroy us. So this asteroid's actually pretty cool, though. If you play around with it on its webpage on NASA, it looks like a potato. It's not a potato that you would want to eat. It would crush you first. So scientists actually think that 16 Psyche is mainly composed of metallic iron and nickel. So it's very similar to Earth's core. So because of this discovery that they've made about Psyche's composition or what it's made of, it's actually led them to wonder whether or not Psyche is an exposed core or not, meaning most rocky planets have a core. So Earth has a core of nickel and iron. And so if the crust of the planet that has a core like this wasn't that thick or protected earlier in the formation of the solar system, they believe that it was possible that the rocky outer layers actually got knocked off because of the violent collisions that happened billions of years ago when the solar system was forming. And we do know that Earth during this time too was just completely molten rock because it kept getting battered and battered by different clumps of rock that were coming in and forming the planet. So it's completely possible that this was a planet that was closer to Mars and kind of lost its planetariness because of the violence that was around for that. So as you can see, meteors, meteoroids, really, and asteroids are quite similar, but they range in size and they can be kind of like throughout the inner and outer solar system. And so they can tell us a lot about our history and the solar system as it was being made, and being able to kind of give us a look back to how our solar system grew into what it is now. And it can also tell us about how asteroids actually impacted Earth before, because we can see that sometimes asteroids like these do have courses where they may come into contact with the Earth. And so it always keeps us on our toes, and it can really explain to us how sometimes orbits can be changed by objects like these. So thank you for listening. And if you have any questions, please feel free to reach out to me at hbuckner@fairbanksmuseum.org. There will be a post-class assignment that will be on the webpage. And as you go through that assignment, feel free to email me with any questions or concerns. If you just want me to check it over, I'd be happy to look at it. And thank you so much for watching, and have a wonderful night. Thank you so much. Or a wonderful day, wonderful afternoon, and actually stay safe, stay well, and remember that by working together, we can fight this virus. So stay safe.